development. So, um, nobody is actually replying. Good morning, everybody. I want someone to say good morning, or you can type it in the comment section. Good morning.
Good morning, sir.
Okay, good morning. Good morning, Abiodun. That's amazing. Peter, okay, Peter says good morning. Very good. Yeah, Tammy, good morning. Damilola, good morning. Yeah. Now we're becoming active. Yeah, so today's class is going to be amazing and it's going to be exceptional because we have an amazing tutor in the building today. But before I introduce the tutor, can anyone tell me what we talked about in the last class? Anyone in the last class?
We talked about computational thinking.
Hmm. Computational thinking. I'm very sure that everybody could remember how to cook noodles after that last class.
Yes, sir. Very well.
Yeah, everybody will remember how to cook noodles. That's very, very important. Okay. So today, like I said earlier, I'll be talking about data structure and algorithms. So without further ado, let me introduce our lecturer for today in the person of Jonathan George, Mr. Jonathan George. Are you active here, Mr. Jonathan?
Yes, I am. Good morning.
Very good. Good morning. It's nice to have you here.
All right. Good morning, everyone. Welcome to today's lecture, data structures and algorithms. So, as the moderator has introduced me, my name is Jonathan George, and we'll try as much as possible to make today's session very, very interactive. I'm coming, kindly give me a minute or two. I want to share my screen. Okay, good morning once again to today's lecture, Data Structure and Algorithms. I'm going to start very, very quickly from the root of today's presentation. Who wants to have a go at what data is or what they think data is? For now, there's no wrong answers. We're just going to interact with ourselves. Let me know what you think data is. Feel free to unmute yourself if such capabilities are available this morning. However, if you cannot unmute yourself, please drop your response in the chat box and I would respond as the case may be. Who wants to have a go at what data is? Hello, can anyone hear me?
Yes,
Yes,
sir. We are
I
with you,
can
sir.
hear you.
Okay, all right. Data.
Data, data is information that can be used for reasoning, discussion, or calculation.
Okay.
From my own understanding, data can be referred to as probably an unprocessed fact or symbol or collation or stored information to be used for different reasons.
Okay. Please, before I proceed, I'm trying to, as I shared my screen right now, I'm trying to get to the chat box. So, just kind of give me a minute, please, so that I do not miss, in case anyone is writing or putting a response in the chat box. Can you see my screen, Ademola?
Yes, I can see a screen, but it shows that the chat box is not loading up. It's just a black background.
Okay, okay.
Mm.
All right. Okay, I think I've seen the solution I'm looking for. So, okay. Hi, good morning. Okay, data are all facts. Yes, that's Jadi Solar. Someone else made a contribution a few seconds ago. Please pardon me. Can you have a go at it again? I was trying to figure out how to work with the chat box while I'm sharing my screen. Who had a go at what data is? Please, can you kindly repeat your answer again?
Yes, sir.
Okay, all right.
Abiodun, sir.
All
I
right,
mean,
please.
data is the information that can be used for reasoning, discussion, or calculation. Uh,
Wonderful.
it might be
Wonderful.
form of numbers, words, measurements, observation, and other description.
Wonderful. Thank you so much, Abiodo. Richard in the chat box equally said data is processed information. Jadisola said data is or are raw facts. Everyone is correct this morning. Thank you for contributing as the case may be. Now, I'm going to begin by painting a couple of scenarios to you.
Sorry, Mr. Jonathan. I can't see your screen. It's just blank here.
Blank. Also, yes, sir.
Okay, all right. Okay, so I'm going to, please, if I miss any response
It's better now.
or any inputs in the chat box, please kindly visit the chat box because while sharing my screen, I'm not seeing the chat box in the immediate. So I'll have to be minimizing my screen, going back to the chat box. So please feel free to draw my attention if anything is put on the chat box and I don't see it immediately. Now, I'm going to, like I said, paint a couple of scenarios to you to enable you understand before I talk about the learning objectives for today as well as next week, because this course, Data Structure and Algorithms, is a 2-week course or program, as the case may be. It's going to be divided between today and next Saturday. Now, the scenarios I'm going to paint to you go thus. Imagine you work at an organization and you are given a task and the instruction goes that you should download a couple of files to work with. Now, these files that are to be downloaded, it involves both yourself and one other of your colleague. Now, you, whomsoever is listening right now, you download these files, and let's assume that they are about 200, just a rough estimate, rough assumption, and you download these 200 files onto your desktop. And you just go to your desktop and paste all 200 files on your desktop. Now, the colleague you're working with downloads all 200 files, goes to his or her desktop, opens 10 new folders on the desktop, and saves the downloaded files, 20 files each per folder. Now, in working with those files or folders, as the case may be, who do you think would be able to have seamless access? Who do you think will be able to retrieve data in an organized fashion? Who do you think would be able to work in, will be able to optimize time in utilizing that data or information as the case may be? I want answers, please. Anybody? Anybody?
Sir, can you repeat the question, please?
Okay, let me use myself as an example now. I'm working with you, Abiodun, and we're asked to download 200 files to carry out an office task at our place of work. Now, I download those 200 files and I dump all the 200 files straight on my desktop.
Yes.
without organizing the files, without segmenting the files, while you, Abiodun, you go to your desktop and you open 10 new folders and you segment and organize the 200 downloaded files into the 10 new folders, 20 files per folder. Now, between myself, who didn't organize my data on my desktop, and you, who organize his data on his desktop, who do you think will be able to optimize time, optimize space, and perform properly with that data?
I'm the one that I'm the ones.
Okay. All right. So you said you yourself will be able to organize it properly. That's fine. Obina said the person that downloaded it and stored it for future use in an organized way. That's fine. Peter said the files that are organized in folders, 20 files per folder. Wonderful. All right. So we are all correct. Now, when it comes to data structure, the reason I brought up that scenario to us this morning is for the purpose of understanding what data structure is. Now, the learning objectives for this course are as follows: introduction to data structure and algorithms, the knowledge of the tools for studying data structure, including symbols, relations, and graphs, understanding set relations and string structure, knowledge of data lifecycle representation, properties of ordered and occupancy with regards to data, understanding the properties of order and linear list, understanding simple linked list and algorithm complexity. I think we're not going to cover everything today because, like I said, it's a 2-week course, so we'll just stop around understanding simple linked list and algorithm complexity. Now, very quickly, computer science, as we know it, is the study of computers and computational systems that involve data representation and process automation rather, pardon me. Now, if we have computer science, basically, and computation have to do with processing data and processing them in automated means, as the case may be. But in order to process data, it first needs to be organized in a proper way. In order to organize data in a proper way, we must first understand what are the types of data that we have. Does anyone want to have a go at it before I list them? Does anyone have any knowledge or assumption on the various types of data? Hello.
I can hear you.
Okay. Let me see if there's any response in the chat box on the types of data. Okay, so no knowledge on the types of data. Okay, so we have a couple of data types. We have the ones we'll be touching on today. We have integer, we have string types, we have Boolean types, and then a couple of other ones. Now, what are integer data types? Integer data types are numbers, basically. What's an integer? A whole number. So if you, let me put this practically right now, not here, I'm sorry. Let me put it for you practically here. If you're given a data type that involves coming 1, 2, 3, 4, 5, 6, 7. Now, this is an integer data type. And let me go back to my slide. A data type determines how computer processes data by defining the possible values for data and the possible functionalities, yes. For example, the integer data type is defined as values from a certain range of positive or negative whole numbers. Exactly, and that's one thing I didn't put here. So it could also be -1, -2, and -3 as the case may be, and so on. So integer just simply means whole number. Data types that are in whole numbers, whether it be negative whole numbers, positive whole numbers, that's the integer data type. With functionalities including addition, subtraction, multiplication, depending on the programming language you're using. The string data type is defined as a sequence of characters. Now I'm also going to put up a practical example on that. Just a second. Okay. All right. I want today's lecture to be successful. All right.
Now, Jonathan, we are still seeing just your slide. So if you're on another screen, we are not seeing that.
Oh, I apologize. Let me correct it. I was on another screen, but let me correct it very quickly. Let me stop sharing and reshare again. Okay, so I was showing for the integer data type. The integer data type, I don't know, can you see my screen right now that is running the Python Jupyter Notebook?
Yes.
Okay, so the integer data type has to do with numbers from the negative value to the positive value, and that could range from -1 to -infinity and +1 to +infinity. And so you have the example, which is the first one I showed here in the first cell or column, as the case may be, or row rather, as the case may be. The second row is the string data type, where I said, okay, I want today's lecture or class, as the case may be, to be successful. Now this is the string data type. Sorry, let me just quickly return to my slide. All right, so we have the Boolean. The Boolean data type is the data type that says true or false, and that could be written. So let me get an example off the top of my head. Today is the first weekend of the month of March. The month of March. Sorry. The first weekend of the month of March. True or false. And usually if you run this code, well, I'm not writing it right now as a programming language, but if you write it as a programming language and run the code, I will revisit that today. Before we end today's lecture, I would write that as a programming language for you, all those data types. You would usually get the response you should get. Now, data types like strings are an example of abstraction, the process of simplifying a concept in order to represent it in a computer. Now, the string data type takes a complex concept like a sentence and represents it in terms of more basic data that a computer can work with. Now, we have in today's 21st century, we're having what is called autonomous vehicles. Am I correct? That are springing up in the market and are becoming a force to reckon with. Now, if you are making use of an autonomous vehicle and you want to communicate, or even if it's not an autonomous vehicle, an autonomous system, as the case may be, and you want to, or I want to communicate with that system, I am not necessarily going to use, okay, let me put it like this. Let me ask a question. Between string data types, integer data types, and Boolean data types, if I'm communicating with an autonomous system being a system that has full control over itself, has been programmed to function alone intelligently. Now, if which is simply just artificial intelligence. If I'm communicating with an autonomous system and I'm to pass an instruction to it, or I'm to have a conversation with it, give it a command, which of the data types do you think I would make use of in communicating with that system? Between the string data type, which uses words and sentences, the integer data type, which is a value of negative to positive numbers, as well as the Boolean data type, which is yes or no.
Yeah, I think it's a string data type.
Okay, very, very good. And so if I'm communicating with a system, I have to see the string data type takes a complex concept like a sentence and represents it in terms of of more basic data that a computer can work with. Now, when a computer compares two strings, it is really comparing the individual numerical character codes corresponding to each characters within the two strings. Now, in this session, we're going to learn how to solve problems by choosing abstractions for complex data. All right, so let's start from the beginning again. Data structure. A data structure is a way of organizing, storing, and managing data efficiently so that it can be accessed and modified easily. And that takes us back to the initial scenarios I painted for everyone at the beginning, highlighting the need to organize data properly, painting the scenario between myself and
Sorry, Mr. Jonathan. I think your screen is not changing. You're still on introduction to.
yes. Okay, so the definition on data structure is coming straight from my head, right? It's not, yes. So I'm going to go back to what's on my screen. I'm giving it straight from my head experience. That's where I'm defining data structure from. So a data structure is a way of organizing, storing, and managing data efficiently so that it can be accessed and modified easily. And so that's why I asked at the beginning between myself and Abiodu, myself who doesn't manage data properly or information properly on my system, and Abiodu who manages data and information properly on his system, who do you think amongst the both of us will be able to assess and modify and by extension optimize time while working with those or that data as the case may be? And the answers were given that Abiodu will be the person who will be successful in managing the data, which was definitely correct. And so that is what data structure is. Now, we're now going to move into tools for studying data structure, symbols and relations, as well as graph. The tools for studying symbols and relations in data structure include LaTeX, which is used for creating structured diagrams of data structures, Microsoft Visio or draw.io for drawing flowcharts and relational diagrams, Graphies, a tool for visualizing data. Okay. Tools for studying graphs. I'm going to return to the tools for symbols and relations ASAP with practical examples on my system. Graphs for fundamentals in data structures. Now, the following tools are going to help you as far as graphs are concerned. Gephi, which is a powerful tool for graph visualization and analysis. Python, a library to work with graphs. If you're into programming, that is Neo4j, that is a graph database for managing and querying complex relationships. Cytoscape, as the case may be. Now, let's quickly return to tools for symbols and relations with a very, very brief practical. And the practical is going to be on draw.io. So let me just quickly start off from the very beginning, right? We want to, can you still see my screen, please?
Yes, yeah, I can see your screen.
Okay, on draw.io. If you have any questions, please feel free to pose the questions to me on the group chat or the chat box, as the case may be, and surely I would respond. If I don't see it, please feel free to.
Sorry, sir. What software are you using right now?
Okay, draw.io. Let me just start off from the beginning.
Can you help us just drop a link in the comment section so people can actually easily get there?
All right, definitely.
Yeah,
Okay.
exactly. Thank you very much, Damola, for drawing his attention to it. So please kindly share in the chat room, especially whatever application you'd be using, so that everybody would follow through with you. I believe some persons are on their laptops, so they can as well launch onto the platform and be able to use it. Thank you.
Okay, so draw.io, I have put it up on the group chat. Can you see it now?
Yes, I can see it on the group chat.
Okay, so let me just start off from the beginning again. I type in draw.io in my search box, my search engine rather. Okay, then I go to create new diagram. Okay, what we want to create in today's diagram is a flowchart. In today's work rather, it's a flowchart. And so I click on flowchart. Now in the, okay, all right, let me just title this Transformation College. Transformation. Please, are you following?
Yes, sir.
Hello.
Yes,
All
sir.
right. Okay. All right. Okay. Now I do not want to save it on my Google Drive because I want it to be easily accessible by me. So I go to Save As. I've renamed it in Save As. A type is an XML file, where then I go to Device. Under where I go to Device, which is my device, and then I click Save. It takes me to the options on my device, and then I click Desktop, and I click Save.
Sorry to
All
cut,
right.
sorry to cut you short, sir. Can you take it again? Because I was also lost too.
Definitely. Okay, so let me close this and start from the beginning. So I type in draw.io on my search engine, and then I click enter. It gives me using my Google Drive. Have you gotten to this place, please?
I have. Yes, I have.
Okay. Then I click on create new diagram. Today, we want to create a flow chart. All right. And so I'm going to click on flow chart. And then I'm going to click on create. Then I want to rename my work. And so I'm going to, under save as, I'm going to, transformation college .draw.io. I'm going to leave the type as it is, which is XML file, bracket .draw.io. Then I'm going to go to my where session or yes, session. No, well, where section rather. I'm going to go to my where section. And I do not want to save on my Google Drive. If you wish to save on your Google Drive, that's fine. I do not want to save on any other place but my own local device. And so I click device. And then I click save. Now the name Transformation College is the name that I renamed it. And then I go to my desktop. Now you can choose to save it wherever you wish to. But I choose to save it on my desktop. So I click desktop and I click save. I'm sure to bring out an error or yes, do I want to replace it? Because I previously created a file and saved it within the desktop. So yes, I want to replace it. I'm going to click yes. Please, did you follow?
Yes, I got it this time
Yes.
around.
Okay, let me see
Honesty, I see your chat in the chat room. You are lost. Have you been found now? Are you following? Honesty, let us know in the chat room. We don't want to leave anybody by the roadside. Okay, Honesty is still lost. Tell us exactly where you got lost. Is it launching onto this platform or what exactly? You can unmute yourself. You can unmute yourself and speak so we'd understand exactly where your challenge is. From the beginning, okay. So that means we're going back to, is it the draw.io to be able to get here?
Draw.io, yes.
Okay, the
Here to
draw.io.
type it, that is my problem.
Okay, Jonathan, can we take that one more time? Just one more time, please.
Okay.
Thank you.
Yes. So, what search engine are you using, please? Honesty. Hi, Honesty.
Honesty, please unmute and speak.
Okay. Sir, which of the search engine am I going to use?
Okay, now the reason I asked that is that you can use any search engine, right? So I'm using Microsoft Edge, and I'm going to close this and start again, straight from the beginning. So I went to my search engine and okay, so I went to my search engine and I typed in rather draw.io. I don't know if you can see it on your screen.
Yes,
If
I'm
my
seeing
screen.
it.
All right, so I typed draw.io and I clicked enter. It will load now. All right, so have you gotten to this point?
Okay.
Yes, have you gotten to this? All right, have you gotten to this point where
That is what I want to make use of my system. Draw.io. It's still loading.
Okay, so it's actually that simple. Once you type it in your search engine, it brings you to this page. Okay, so if you're having a slow network, it might slow us down, but just know that once you type draw.io in your search engine, it brings you here. And yes, next please, Jonathan.
Okay, so then I click create new diagram. And again, I click flowchart because flowchart is what we want to work on this morning. And I click create. Now, I'm going to rename my flowchart, as I earlier said, to Transformation College .draw.io. I do not want to save on my Google Drive. So what's my best option? I want it to be on my local device in such a way that I can always access it even in the absence of internet connection. So I click save. And then it's still going to ask me if I want to replace it. And I click yes. It takes me to the home page. Okay. Now we want to create a simple flowchart diagram. I'm going to delete this, going to delete everything so that we can start from basic. Okay, so I'm going to start with this. And I'm going to name it Sunday. Church service. Please, if you have any questions, feel free to ask. How I got this, what's the word to use now? How I got this shape or diagram, as the case may be, I came to, within the flow diagram homepage, I came to where we can see the shapes drawn here. And I just chose the shape I wanted. So I wanted the first to be the square. And I just clicked on the square and it appeared. I clicked on the shape and I dragged it with my mouse and I got what I have here. Now, how I typed in it, I double clicked on it and my cursor appeared within it. And I began typing, and you can type whatsoever you want to type, depending on what you are working on. Now, I want to connect that shape to, sorry.
Excuse me, sir, I have a question.
Oh, please.
I think in flowcharts, during the process of the flowchart, I think there are different symbols that indicate the different process of the diagram. Like now, square, this square means maybe process, yeah, and the other thing, circle means start, maybe something like that. So during this, as this examples like this, can we use any symbol to any object to indicate the diagram?
Okay, just a minute, please. Use of, so I'm teaching, okay, do you know how to, you are proficient already in flowchart? Hello, please. Who asked the question now?
I'm the ones I'm with you.
Okay, so are you proficient already in flowchart?
Not that much, but during last semester we learned about that, sir.
During school.
Okay, so for this example, we're going to you're very correct that it means different things, but for this example, we're going to make use of, we're just going to teach how to create the flow chart. And so you're going
Alright.
to, yes, you're going to receive the slide. Next week, we can go into details on, okay, this is what each symbol means within the flow chart and the like. So today we're just going to teach for the people or the persons who are not proficient in making use of flowcharts. We're just going to teach them how to create the flowcharts in the first place. Okay, so you can link the Honesty, are you following, please? Hello.
Hello, I'm with you. I'm with you here.
I'm with you, sir.
Okay. First day at work. And so on and so on. I wouldn't go necessarily into every detail. So this is just like an introductory example on how to create your flow chart. Sorry, is someone speaking? Is someone speaking, please?
Sir, you can continue.
Okay. Okay, so this is
Hello, sir.
yes, please.
Okay, I just created the flow chart now. So how to navigate from there? That is my question.
Okay, so you are in the home page, right?
Yes, I'm the home page now.
Okay, so like I wasn't able to figure out the name of the person who spoke about the use of the different shapes for different what's the word now, utilities within a flowchart diagram, but the person was correct. Now, like the person rightly said, different shapes are used for different
Sorry,
utilities
Mr.
within
Jonathan.
flowchart.
That's Abiodun.
Oh, okay, Abiodun. All right, thank you so much, Abiodun. So like Abiodun rightly said, different shapes are used for different utilities during a flowchart diagram creation or application. However, today we're just touching on the introduction around flowchart diagram. We can go into the different utilities for the different shapes next week, because like I said, it's a 2-week program or course. So we'll go into such details unfailingly next week. So today, are you at this part of the homepage that my screen is projecting? Honesty.
Yes, I'm there.
Okay. So for the introduction or the introductory stage today, you can just click on any of the shapes you want to use today. Let's forget about the formalities involved in what shape represents what. We'll go into that next week. But today, let's touch on any shape you want to use. Just click on it. It automatically appears on the home's the draw board, or yes, the draw board, and then you can shift it, click on it, and drag it with your mouse to any part of the screen you want to put it. You might have need for connectors. The connectors could include the curve that I'm highlighting at the moment. It could include the bidirectional arrow. It could include the single directional arrow, as the case may be. Now, if, for example, you've seen the first shape that I clicked on that I'm currently hovering around. Now, if I want to connect it to another shape, I could click on this bidirectional arrow, right? And
Hello, I can't hear you, Mr. Jonathan.
yes, I'm here with you. I'm doing a practical on
All
it
right.
right now. That's why I'm quiet. Okay, so I could click on this bidirectional arrow, right? And okay, let me just click on it again so that you see. Let me delete this. Delete this too. All right. Let me drag this here, and then let me click on my bidirectional arrow again. So what I want to do is resize it or reshape it in such a way that it connects both shapes. Just a minute, I'm trying to get the, all right. Now, you can only drag it when your cursor appears like this. Now, if my cursor is appearing like this, honestly, I do not know if you're following. If my cursor is appearing in black,
I'm with you, sir.
okay, if my cursor is appearing in black, I'm not going to be able to drag it properly. So you're going to see things like this. It's going to just be reconfiguring the shape or the figure rather of the bidirectional arrow. Now, when my cursor becomes this way it is right now, four pointed, in my screen it's white. Hopefully it's white in your screen as well. Now, when my cursor becomes like this, then I'm able to drag it. And I could also resize it. Okay, so here I am resizing it because I do not want it to be, I do not want it to occupy too much space as the case may be. So I've resized it, and then I bring my next shape or yes, shape close to it. So you can see that the bidirectional arrow links the first shape, which is this first one here, to the second one. And then you can make any inputs to it as you so desire, depending on what you're working on. Like I said, next week we'll touch on the specifics on what the shapes represent and the utilities of each shape as far as the professional application of draw.io is concerned. Now, that's it for the introductory stage to flowcharts. You can definitely always go on and practice further on your own. There are all sorts of materials and tools to use to practice. Now, tools for studying graph. I don't know if anybody has a Python application. I know that yesterday, I don't know if anybody here was part of the artificial intelligence or is part of the artificial intelligence program that is going on at Transformation College. If you are, then you should have Python installed on your system. Does anyone have Python installed on their system here?
I have Python on my system.
I also
Oh,
have Python in the system too.
oh, okay, that's very good. Okay, so just a minute, please, or a second. Okay, so we're going to go to Python. You know how to use Python? I know you have it installed on your system, but do you know how to use it? So what I'm going
No.
to,
Not very
okay,
well.
okay. So I'm going to let me, how do I do this now? All right. So this is, if I go to, how did you install yours? Did you install yours using Anaconda?
Yes, sir.
Okay. So if you go to Anaconda, here's Anaconda. You go to Jupyter Notebook within your Anaconda.
So we can't see your screen. There's a blank
Hi,
box
I
in the middle.
apologize. I understand. I understand where the issue is coming from. Just a second, please. Let me fix it. How do I share all? No, sound. I want to share all. No, not that. No. Okay. I know what to do. Okay. All right. So you're going to see it now. So if you go to Jupyter Notebook, can you see my screen now, please?
Yes, I can.
Okay, so if you go to Anaconda, rather, not Jupyter Notebook, if you go to Anaconda, here is Jupyter Notebook. You just scroll down and look for Jupyter Notebook. If you installed it properly, you're supposed to have Jupyter Notebook by now.
Sorry,
Uh,
sorry, sir. Because I'm thinking there are a lot of people that don't have Python and don't understand how to get to this Anaconda navigator. So if there's a way you could just make it easier for them to be able to get it, if they can do this setup later and we'll continue the class, it will help them
okay,
to catch up.
yes, definitely. Let me just quickly get the URL for downloading Anaconda and I'll post it on the group chat.
Excellent, sir. Thank you.
Yes, post it on the group chat now so that e e e. All right. Yes. Okay, so let me quickly. I think there should be. I just want to make a confirmation on. All right, so yes. So let me just post this on the group chat very quickly. Okay, Obina commented that he didn't have Python. All right, so okay, so that's the link. Now, when you get to the link for download for that link I just posted right now, it will take you to this page, right? Under the products. Okay, so it will take you to this link, right? And you just click on free download, right? And it takes you to, no, this is not what I want. All right, so let me just run instead of the previous link I posted. Uh, sure, you can use Google Colab. However, definitely you can use Google Colab for this class if that would suffice for you. However, the challenge with using Google Colab is that Google Colab only provides you with minimal, if you're working on large data sets, so Google Colab would not suffice for you. You're going to have to make payments because Google Colab is mainly a cloud service, if I remember correctly. It's mainly a cloud service, and so they will give you what's the word now? There's a technical word for this now. They will give you the instruments for you to be able to run your machine learning. However, when it gets to a certain point in running your data sets on Google Colab, it will tell you cannot proceed. You are just going to have to pay for more space on the cloud. So it's always better to make use of Python. Python is open source and is free, and that's the beauty of Python. The only thing about Python is that when you get to a certain time, you might have to upgrade the RAM of your system. Otherwise, it's far more optimal than any other platform, as far as I'm concerned. So, yes, you can make use of Google Colab for today's work or project, as the case may be. Yes, I know my screen is not showing right now, so don't worry. I'm going to sort that out. I want to quickly just run a sample code for the graphs in if that would help. All right. Any questions thus far, please? Hello. Are we following? Let me call persons randomly to see who is paying attention and who is following and who has challenges with today's class.
People are asking questions in the chat box. Can we use VS Code? Can we use PyCharm?
Okay. VS Code, I would be honest with you. Okay, so you can run some, I know that you can run some Python codes on VS Code. Now, what I do not know are the dependencies that you're going to need to run those or the extensions that you're going to need to run those codes. My forte is Python, so I use Python for now. What I also know is that you should be able to use Google Colab as long as the data set is small. But you are definitely going to run into challenges if you are making use of real world data sets for real world data science applications or programming applications. Google Colab will not suffice unless you're willing to pay for subscription on the cloud, which might not be feasible as the case may be. So what I know for now is, let me look at the chat box again. I think we have one more question. I heard you talk about a group earlier. I'm not on a group if there's one. I only joined the class via my email. Okay, I wasn't talking, what I was talking about was an AI class still run by Transformation College of Business and Technology. So it's not a group per se, it's a class. And if you're not on that class yet, I know that the moderator, as well as my boss, would definitely speak about the class later on. You should join that class. It will help you as far as going in depth into programming and programming languages are concerned for data science. So the moderator and my boss would definitely speak more with regards to that. Let me just quickly get this practical example for you on graphs using Python. What I did for the few persons who have Python, for those who don't have, I've dropped the Anaconda link for you. For the few persons who have Python, what I did is I go to new, then I go to Python 3. I do not know if you're following for the persons who have Python. And then I click,
Yes, I'm following.
okay, and then I click new. Now, this is an example code that I'm going to use to run this for you. This is not my own code. This is an example code. I want to use it to run the graph for you. Okay, so this is we're still going to visit this as the class, one of the graphs that we are going to be discussing or focusing on. As you can see, it shows the nodes and the points. that are displayed or that you want to create. This is almost like a tree graph, or yeah, but we're going to visit it right now. That's just basically how to make use of Python. For representing your data in graphical formats, as the case may be. Now, for hands-on learning and visualization of data structures, we have Disu Algo, we have CS50 Visualizer, we have Algorithm Visualizer. For graphical visualization, I would still suggest Python. Right, I would still suggest Python. It's far more easier to work open source, and you just need to know one or two codes that you're working, be able to get your represent your data in graphical format, as the case may be. Now, understanding set relations and string structure. What is a set to start with? A set is a collection of unique items. And so let me simplify it for us. If I have Now, if I want to park out of my immediate location, if I want to relocate from my immediate location, and I hire a moving truck to move my things, my belongings rather comprise of a fan, a bed, a sofa, and a TV set. Let's assume that's all I have. A fan, a sofa, a bed, and a TV set. That's about 4 items. Those 4 items, all unique, none of them coming twice or repeating twice, are called sets. In my own case, you can call them a set of my set of belongings. Or you can also call them my set of, set of belongings would be much more appropriate. And so a set is a collection of unique items that are represented in data formats. Let me show you an example, again, using Python. Okay, so I have television, I have a bed, I have a fan, I have a sofa. And so this right here is my set, right? Okay, so I'm going to walk around that. I made an error in my code. And so, but this right here is my set. This is the television, the bed, the fan, and the sofa, right? And so that's what we're talking about when we talk about sets. Now, in computer science, sets help organize data without duplicates. And so in the event where you see
Hello.
Yes, can you hear me?
Yeah, I can hear you. The network was breaking for a bit from your end, that's why.
Oh, okay. Okay, so in the event where you see this right here that is highlighted, this is no longer a set, right? And so a set is just a minute, a second, and a collection of unique items arranged with lists. Could be an array, it could be, yes, a list, an array. It could also, well, in some cases, it could also be a linked list, right? Now, just a second. A relation shows how elements from one elements in another set. Now, imagine a school where students are assigned to different teachers. Relationship between the students and the teachers. The students being one set and teachers being another set. The teachers being a set because each teacher within the set of teachers is a unique entity, is yes, a unique entity, an individual of himself. Yeah. And each element, as the case may be, within the set of students is also or equally a unique entity or a unique character or a unique yes, a unique figure within that set. Now, a string is a sequence of characters like words in a sentence. For example, hello world is a string. A string could also be what I showed earlier. I want today's lecture to be successful. Now, that's a string. So, like this said, a string is a sequence of characters like words in a sentence for programming because they help store and manipulate text. Now, how many of us have what's the word now? Let me ask this question. What's the favorite artificial intelligence tool that we work with? Hello?
So can
Hello?
you ask the
Hello?
question? Chat.
Okay, so what's the
ChatGPT.
okay, ChatGPT. Now, okay, I think that question is cliche at the moment. Let me rephrase it. How many of us have come in contact with videos of robotics, of robots, human robotics? How many of us are aware of humanoid robotics? The likes of Tesla, the likes of uh, yeah, and so on.
Where?
How many of us have come in contact with videos or developmental strides in humanoid robotics?
I have seen some Tesla robotics when they did the launch, I think late last year.
Okay. And you have seen those robots converse with humans, right?
Yes, yes.
Yes, severally.
Okay. Now, the ability for the robot, as the case may be, to be able to form words or put sentences together is made possible because of the programming structure utilized by something called natural programming language, um, natural language programming, NLP, is a programming type used to program AI to be able to form sentences using strings. String structures, which we just looked at right now, which is a sequence of characters used to form sentences and communicate I don't want to use the word now, English, used to communicate verbally. between two autonomous individuals. And so string structures or string data types are used to program artificial intelligence, computers, machines, and autonomous digital figures in knowing how to communicate verbally with the human world, as the case may be. Now, we're quickly going to move on to the next part of this, which is data lifecycle representation, the properties of ordered and occupancy. What is data lifecycle? Now, data lifecycle involves the creation, the storage, the usage, the creation, the storage, the usage, the sharing, as well as either archiving or deletion of data. Now, in the course of understanding the data lifecycle in relationship with in the course of understanding the data lifecycle, pardon me, please, I was receiving a call. That was a brief distraction. Understanding the data lifecycle in relationship with data structure, we have to take into cognizance the fact that, or understand the fact that when creating data, before that data is stored, we must understand what's the storage capacity we have at hand. And so if we understand that our storage capacity, back to the initial scenario I painted at the beginning, if we understand that my hard drive has, let's assume, a storage capacity of 8 gigabytes. Data files are created, and within the office space, I'm given a responsibility and say, work with this and this data to achieve this and this result, right? If I want to optimize my data storage capacity, I will first and foremost have to structure my data in an organized format in such a way that I'm able to tell this is the priority amongst the files or the data that I've been given to handle. This is the most important one, and so it should stay on my hard drive. This is the less important one. Now, it mustn't necessarily be hard drive. It could also be a cloud system. This is the less important one, and so I save it to an external storage device. I structure my system in such a way that by the time I'm done analyzing, processing the data that is stored on my system, I can then forward it or share it to the appropriate authorities or with the appropriate authorities, as the case may be, and delete it. That is, delete the data or the information that I have processed as per my work instructions. And then I transfer the data that I stored on an external device back to my system. And I go around the cycle again. It's stored on my system. I use it. I process it. I then share it or forward it to or with the appropriate authorities. And then I delete it. But to be able to successfully go around this process or procedure, I have to first and foremost understand what is my data type? What is the size of my data type? And how do I structure my data around its life cycle? Again, data life cycle goes from the creation to the deletion of data. Any questions, please? Please, if I'm not carrying you along properly, please
from my
let
side.
me know.
Continue, sir.
Carry on, sir.
All right. All right. So onto the properties of ordered and occupancy. Now, the properties of ordered refers to whether data follows a specific order. And in that regard, we have things. I'm just going to give an example for that. Now, if I have a list, all right, and the items within that list says I have my properties include, again, I'm going to use the initial properties I use: a bed, a fan, a laptop, cooking utensils, television set. Now, in ascending and descending order, and so order can be either ascending or descending. In ascending order, we start from the list. In this case, using what do we call it now? Alphabetical order. We should start from rightly bed. We should follow up by fan. We should follow up by cooking utensils. Because, we should start from bed. We should follow up by cooking utensils. We should follow up by fan.
Sorry, someone's mic is on, and I think there is feedback all over. Can the person please?
Honestly, please, if you're not speaking, do not unmute your mic, please. If you don't have a question or you are not, you don't have an input at the moment, please do not unmute because we're getting feedback from your end. Thank you. All right, Jonathan, let's go ahead, please.
Okay. Okay, so now, in an ordered set, we should start from bed in alphabetical order, and that should move to cooking utensils, and that should move to, let me write this down again, bed, cooking utensils, fan, television set. Now, this is ordered in an alphabetical format, right? This first one is not ordered. And so you can see bed, fan, laptop, cooking utensils, television sets. There's no alphabetical order to it. It can be set for a data set of, say, 5, 10, 2, 23, 0. Now, this is a disorganized data set. It's disordered. It's not ordered in a numerical form. But if we have a data set that goes thus, so 0, 1, 2, 3, 4, 5, 6. Now, this is an ordered or sorted data set in numerical form or numerical format. And so properties of orders is where it refers to whether the data follows a specific order, be it numerical or alphabetical order. Examples are list of students sorted by grades or alphabetically, while a random list of students is disordered. Now, for occupancy, this describes how much space a data takes up, which takes me or us rather back to the scenario I painted with the data lifecycle management. And so imagine a bookshelf where a number of books have occupied all the space, and the library that owns that bookshelf orders more books. Where do we think the new books that are ordered will stay if there's no more space in the library? And so the data runs into another field of data science called data security. The data becomes unprotected because it's not properly structured. So, it's scattered. At that point in time, you cannot necessarily give proper account for where the data is. And so occupancy is a key or prime factor as far as data management is concerned. You want to ensure that the data you are managing or have custody of, the data is properly structured in such a way that it meets the space available in your memory device. Now, that memory device could be in your physical device. It could also be in your cloud device. It could also be in your external device. External device being memory card, hard drives, and the likes, right? And so you want to also take into cognizance issues of occupancy as far as your data structure is concerned. Organize your data in such a way that your get full easily. You are deleting when you're supposed to delete. You know what's the prime data that I need. That would go into, we are still going to look at it, something that talks on first in, first out, last in, last out. We're going to look at that as we proceed in data structure. So understand the properties of order and linear list. Now, for properties of order, this means whether the data follows a specific sequence. We've spoken about that already. A to Z for alphabetical data, or 0 to the highest number for numerical data. And so other data, a list of students sorted by their names, that's A to Z. For example, if you go to your desktop on your laptop device or your computer device, you can always order your files. For those of us, I don't know, should I put you through physically on how to order files, or we have an idea on how to order files? If you want me to put you through physically on that, I can, but in the absence of any request to do so, I'll just proceed. Now, on order data is a random list of items. Now, that could be anything. It could be my property. It could be data on student grades. It could be data on the states within Nigeria. It could be data on revenue, a random list of items or data with no particular arrangement. And that's a disorganized data. If you're going to access data from such a structure, it might put you through certain challenges that will not necessarily augur well for optimizing the data in question. Now, a linear list is a type of data structure where elements are arranged in a straight line. And so you have that example here again. This is an example of a linear list. The items within the elements rather within the set is within the set is organized in a straight line. Examples are a queue at a movie theater. Now, yes, okay, a queue at a movie theater, a to-do list where tasks are completed in sequence. Now, for things like a queue at a movie theater, we'll still visit that. We can use things like first in, first out would suffice for a queue at a movie theater. We can also use things like, right? For example, we all have music devices on our phones, as the case may be, music applications rather, devices, as the case may be. If we go through those music playlists in those devices, music applications, you'd find that if you press or you start listening to one song, many a times, depending on the way you program the device or the application rather, the music or the song just moves straight on to the next one. And so that makes use of something called, going to touch on as this class proceeds, okay, which is already here. Now, types of linear list includes arrays, like list of students' names. For example, let me quickly just show an example of an array. Okay, so for example, for an array, we have student names, Jonathan, Michael, Samson, and the like. So now you find that this is ordered. In this case, it's an ordered array. A flexible list is where each item points to the next. A flexible list, rather, where each item points to the next. Now, that's a linked list. An example of a linked list will be shown beneath. List of plates, last in, first out. We're still going to look at that either this week or next week. In line, first in, first out. Yes, which is what I remember just speaking about a few minutes ago with music playlist. If you I think I spoke about music playlist and as well as a movie theater. I can't remember if I spoke. And so if you're trying to program the way an artificial intelligence or a computer program should respond to people on a waiting line, you make use of what's called a first in, first out structure and algorithm for your data in such a way that the first element that comes into the set or the link or the array that comes into the set, rather, the first element that comes into the set is the first element that will be responded to. Now, real life applications for that include things like call centers, places like yes, movie theaters, also places like a music playlist where you've ordered it to proceed without repetition and without shuffling. You've ordered it to proceed in with which you listed the songs. Now, those are just a few random examples for first in, first out for the data structure. Now, we have under properties of order and linear list, we have a simple linked list. That is a linked list being a type of data called a node, stores two things: the data or the in question, and a pointer or a link to the next data in question, right? And so, what's the best real life scenario for this now? Okay, I think one is listed here. Think of it like a train where each coach is connected.
Hello, everyone. Sorry about that one. I think we just had the network glitch, so let's take a few minutes while he reconnects. But pending that time, how's the class been so far? Have you been following? And if you're lost, let us know on the comment section so we can know how to, get you back on track. Can anyone hear me?
Yes.
Yes, I
Yes,
can
we
hear you.
can hear you.
Okay, that's good. That's amazing.
You are
So,
very good.
are we following the class? Is everybody
I
up to
have
date?
issue with the where you are entering your program. Which particular software are you using? So that we can still type our own program the way you are doing it.
For this class, majorly we are using Python so that it will be easy for you to be able to run your programs and you will not need to pay later on, because when you install Python, you use Python, you will not have any issue of payment necessary. There'll be restrictions if you use some other softwares. There'll be restrictions later on, like for example, if you are using Spotify, if you play few music, after a while they'll tell you to subscribe to get a better access. So using Python is like using an open source where you don't need to pay and you can maximize your potential on it.
Is it
So
book?
do you understand that, honestly?
Okay.
Hello, are you with me?
Yes, I'm with you, sir.
So it's just best for you to get Python installed on your computer. You can go to our YouTube channel. On the first class, we showed you how you can install Python, how you can set everything up there, and that would make everything easy. I think you are using two devices to join
Yes.
this. So you need to reduce the volume to barest
Okay.
minimum or the other ones. That's why we have a feedback of that noise.
Okay.
All right, thank you very much. Is there any other person that has a question, or you are lost somewhere, you need guidance from somewhere on this particular class? Okay, I can see that Damilari is actually requesting for the attendance. You'll get it shortly. So far, how would you rate the class right now? How would you rate the class? How would you rate your trainer so far?
For me, the class has really been, yeah, I've been learning a lot. So if we were to give a scale of 10, I don't know, I will still say 8 for my own parts, sir. Yes, sir. And I would love
That's
to ask equally, how long is the um class going to take? I mean, in terms of durations and days, because I was hearing this week and next week.
From MTN to Airtel.
Okay.
Kindly forgive me.
No problem. Everybody knows about
Hello.
how things work in Nigeria regarding internet and the network. It's good to have
Hello.
you.
Okay.
You can proceed, sir.
Okay. All right. Can I proceed?
Yes, you can.
Yes, sir.
You can.
Okay. Now, okay, so linked list, and I said it's synonymous with train carriages where each coach links to the other, use physical
Sorry,
links,
Mr. Jonathan, we can't see your
meta.
screen.
Okay, my screen.
Yes.
I apologize. I apologize.
And for Mr. Michael, I'll send you a reply to your question via the chat box. So Mr. Jonathan can continue with the class.
Okay, so all right, so
Can't really hear what you're saying.
just
There's freaking transmission.
Hello, Mr. Jonathan, are you here with us? Hello.
hello.
Hello, we can't hear you properly. The network is glitching. I'm sorry now.
Okay, please let me just quickly reshare my screen. Okay. Now, the advantages of linked list involve the fact that you can always expand them at any point in time. Now, they are not static. They're dynamic out of whatsoever you are processing in such data or in such context, as the case may be. Am I audible enough, please?
Yes, you are. The network is far better now.
Yes, you are.
Oh. Okay, all right. Now, as far as algorithm complexity is concerned, there are four types of algorithmic complexity, and I'm going to show practical examples on that using Python again. The first is the constant time algorithmic complexity, where the algorithm runs in the same time, no matter the data size. For example, if you want to access the first elements in an array or a list. The second is the linear time algorithmic complexity, where the time increases as the data equally increases. And so if you're searching for an element in a linked list, if you remember, a linked list is dynamic. And so a linked list is dynamic, is flexible. In other words, it expands as the need arises. And so you can always add more elements to your data set as long as it's a linked list and there's need for it. Now, the third is the quadratic time, where time grows exponentially or fast. And so you have cases like nested loops and the likes. The fourth is the logarithmic time, which is exceedingly efficient for large data sets where we carry out things like binary search. Now I'm going to just quickly for all of them. Right. Here, just kindly give me a few seconds to close this, close this, close this, close this, close this, close this, close this. All right. Okay, so here is the first, where, for example, the first constant time complexity, where I want to access the first element in an array or a list, as the case may be. And the first element is always 0. Now, in programming languages, when it comes to data structures for lists and arrays, we always start what is called an indexing. An indexing is the position of an element in a list or an array. And so for a list in Python, the indexing always starts from 0, 1, 2, 3, as the case may be. In other words, the first element in this list, which is 10, for the first element, which is 10, the index is 0. The second, which is 20, the index is 1. The third, which is 30, the index is 2, and so on and so forth. Now, we want to find given a set or a list as this, we want to find our first index or our first element. The first element being the first index, which is 0. It's very simple, because if I want to find, let's say, for example, what's the first item in my room when I step into my room? Okay, it's my foot mat. And so once I open the door, it's very simple. I do not need to go around searching. I'm not going to spend time. It's the same thing that applies to a data set. And so the first index or the first item or the first element, as the case may be, in my data set or list, yeah, as the case may be, again, is 10. Hence, I'm not going to spend time, meaning that that's how we derive the term constant time complexity. The execution time does not change, no matter the amount of items or elements within the data set. No matter the amount of items or elements within my room, the time it takes me to find my foot mat doesn't change, because my foot mat is just the first thing I see when I walk into my room. The same thing for this data set. The first element you see when you look at the data set is 10. And so for the algorithm, it doesn't take it any time to find that value of 10. The time remains constant, no matter the amount of elements or jargons within the data set. The algorithm spends the same time to find the first element. Now, linear time complexity, where the execution time is, we have an example of searching for an element in an unsorted list. Okay, so I actually use the sorted list for this, right? But I was supposed to use an unsorted list. Let me just change it to an unsorted list. Okay. Very quickly, 2000, yeah, 2050, 14, 22, 1 million. All right, so let me run it again. Okay. Okay, so I was looking for, right, let me just add 30 to it. Okay, found. Now this, okay, so the input size here, am I still audible enough, please? Hello.
Yes, very audible.
Yes, you're audible.
Okay.
You're audible.
Okay. Any questions thus far, please? Any questions thus far, please? All right, I take it there are no questions. Let me proceed. And so the input size for this data set is still small. Now, if you're dealing with data sets for real life or real world applications, you could have a data set with number of elements reaching about 1 million, reaching about 2 million, as the case may be. It could be about 10,000, it varies, but you're going to have way more larger data sets than this. Now, what happens let me relate it to real life scenarios. What happens if I step into my room and, for example, my room is scattered and my room is exceedingly scattered and I'm looking for my pen within that disarranged, disordered room. Definitely, I'm going to spend time, right? And so that's what this linear time complexity speaks to. The execution time grows proportionally with the input size. And so if my room is very scattered with a whole lot of things, I'm definitely going to spend a lot of time looking for my pen. However, if I come into my room and my room is, yes, still scattered, but let's assume I'm moving out, again, the scenario of my relocation from my present environment, and I step into my room, and my room only has, I've moved a lot of items out, but my room only has a bucket, my writing materials, my laptop, my bedspread, and the likes, but my room is still scattered. Within these few items, it's going to take me only a much more less comparable time to find my pen compared to if all my items were in the house and I'm not moving out and the whole place is scattered and I'm within that huge dump of scattered items, I'm looking for my pen, right? So linear time complexity, the execution time grows proportionally for the algorithm in searching for an element proportionally with the input size within the data or the data set, as the case may be. All right. Now, for the quadratic time complexity, execution time grows exponentially or fast as input increases. And so we have examples like nested loops or checking for pairs within a loop. And so you have
Questions?
yes, please.
Tammy, can
Yeah,
speak.
take me over to you.
All right, thank you. Sir, please, what would be the algorithm complexity if the link was sorted?
Okay, so if the link was
If the
okay,
link
so
was
if the link
sorted, the former one.
for this one, if the link was sorted, you can still use linear time complexity, right? But it definitely is going to take less time, right? It's definitely going to take less time because it's in an ordered format. You can also use constant time complexity, right? Why? Because it's ordered. And so you know what you're looking for. You can always say this is at this point. Now, if it's ordered, for example, again, I'll use the scenario for my pen, or let me just use this right here that we're looking at, right? Now, if I'm looking for this is a list that says 10, 20, 30, 40, 50. Now, if I'm looking for 50 within this data set, I can always just direct my data set to say, give me the index that says 50 found and give me the position where it is, right? Because it's ordered. Sorting through that ordered data set would not be a problem for the algorithm, right? it can easily pick and say, okay, after 10 is 20. This is the order, variables of 10. After 10 is 20. After 20 is 30. After 30 is 40 and the likes. And it just goes straight on. And it gives me the index plus the element in question. Right? Does that answer your question, please?
Yes, sir. Thank you.
All right. All right. Um, okay, so now if you're looking for pairs in a list, the execution time would definitely increase, right? As the input increases. And definitely you can understand that. Let me use a real life scenario right now. So again, I'm trying to order, again, a scattered environment, assuming my apartment is very scattered and untidy. And I'm trying to find, I have 4 pairs of shoes.
Sorry to cut you, Mr. Jonathan.
Yes, please.
We'll be going on break shortly, but I would like you to round up before we take that break. So I'm just
Okay.
taking time to inform you that I'll be going on break shortly.
Okay. All right.
Thank
And
you.
I'm trying to find my pairs of shoes, my pairs of footwear in general, right? That includes my slippers, my shoes, my sandals, in the case where I have one, right? Now it's going to take me probably more time in an exceedingly scattered environment. Here's why. I might come into my room, I see, like my whole box, I emptied my whole box. Everything is on the floor. My shoes, everything is on the floor, including my writing items. My laptop is in one corner. This one is scattered here. My bathroom things, my cooking utensils, everything is just poured around the room. The whole place is a mess. And so I find my right leg out of my pair of sandals, and I start looking for my left leg, for the left side of my pair of sandals. I can find the left side of my pair of shoes, and I start looking for the right side, right? And it takes me more time. Why? Because the more scattered items I have in the room, the more I have to dig through those scattered items to find, oh, because the pairs definitely are not together. Why? Because they are scattered, right? Now, in the event where the pairs are together, right? In the event where uh, the data set is ordered in a proper format, in a proper fashion, you do not necessarily need to go through the quadratic time complexity for the algorithmic complexity. Definitely the algorithm would use a much more simpler method to, before I proceed, or let's do it like this. Let's go on the break. When we come back, I will continue from here. Is that okay?
Yes, that's okay.
Algorithmic complexity is where we are. We'll continue from there once we come back from the break.
All right, so we're going on break now and we'll be back by 12:30. It's a 30 minutes break. So please come back on time so we can continue from where we stopped. Thank you and see you by 12:30.
So without any further ado, I would like to welcome back our lecturer, Mr. Jonathan. Are you here?
Yes,
Can you
I
hear?
am. Yes, I am.
All right.
All right.
Perfect.
Welcome back.
We can resume our flights now.
All right. All right. Welcome back. I believe we're all refreshed and ready to continue or proceed. Just a minute, please. Let me quickly share my screen again. Okay. All right. So we were at. All right, so let's continue. Let's proceed from understanding different sorting and searching techniques. Sorting and searching are fundamental techniques in computer science to organize and find data efficiently. Definitely, because when you have data, the whole purpose of generating data is to be able to interact with it and process the data in question. Now, how do you process data if you cannot find it? And to be able to find elements within a large data set, you must be able to search for it. And that's where data organization and data structure, proper data organization, proper data structure come into question. Now, sorting is the orderliness of that data, organizing it from in an orderly fashion from top to bottom, as the case may be, in numerical order or alphabetical order. Now, searching helps find an element in a list or data structure. Linear search involves checks each element one by one. Example, searching for a name in an unsorted list. A disorganized list where you're looking for a name, it has to check each element one by one. The Python code example is below where it says define linear search. You have the array and then you have the target element it's looking for, all defined. And it says for I in the range or the length of the array, you search for if the array has the target return I, and if the target is not found, return -1 being a common way of denoting in programming languages where you are not able to find an element that you're looking for within you're not able to find an element you're looking for within a, a context of programming languages in as far as data sets are concerned. Then it says understanding sorting and searching techniques. Yes, you have also, aside from the linear search technique, you also have the binary search technique where the algorithm divides the data set into two and into two equal halves, if I may add, into two equal halves, and sorts for within each half, checks, okay, where is the target element most likely to dwell, the first half or the second half of the division of the data set, as the case may be. If I'm not putting this in, if I'm not breaking this down properly, please let me know so that I retake it again. And so a vivid example of this would be in the event where you're searching a dictionary, for example. So I take a dictionary and I'm looking for the word let's say I'm looking for the word light. And I open the dictionary, I divide the dictionary into two. Light is, L is the A, B, C, D, E, F, G, H, I, J, K, L. Okay, L is the 12th letter in the alphabet out of 26. Yes, out of 26, that means it will be in the first half. And so when you divide the alphabet, when you divide the alphabet or the dictionary rather into two, you find that the middle will lay in M. And then you start sorting. From there, you start searching rather. And you say, okay, where does L, light is L? And where does L come? Before or after M? It comes before M. And so you go to the left side of the dictionary, which is where you find L, which is A to L. Yes, you find L there. And then you're able to find the target element within the first half of your data set, as the case may be. It's the same thing that applies with binary search. The algorithm divides the data set into two equal halves and then goes to look, okay, where is this target element most likely to be? The first half or the second half? And it looks at, depending on the arrangement of the data set, it looks and says, okay, it only works in a sorted list, and looks and says, okay, if the target variable, for example, if it's numericals, if the target element, rather not variable, if the target element is 5 in a data set of 1 to 10, it looks at it and says, okay, 5 is the middle, so there's no need to searching around. I just collect 5. If the target element is 4, it looks at it and says, okay, 4 comes in the first half of the data set, and it goes to the first half of the data set. If the data set target element is 8, it says, okay, 8 comes in the second half of the data set, and then it goes to look into the second half of the data set. Any questions, please? I would now actively be calling on people to participate. Rufai. Hello, Rufai. Hello, Rufai.
Yeah, hi.
Please.
Good afternoon.
Good afternoon, brother. Okay. Any questions so far?
For now, no questions so far.
You're following?
Although I think, yeah, I'm following. I know that after this section of this class, you're going to send the what's it called, the
The
documentation
material.
of this yeah, material. Yeah.
Yes, yes, definitely. So you are up to speed thus far?
Sure, no problem.
All right. Marvin, hi, Marvin.
Hi, how's it going?
Very well, thank you. You? Any questions thus far?
No, none so far.
You understanding the
Yes,
way?
yes, I'm
All
familiar
right,
with it.
all right, all right. Thank you very much. All right, let me proceed from here. So that's that for binary search. Understanding still within the context of understanding sorting and searching techniques. Now we're on to sorting techniques. The first would be the bubble sort, which compares adjacent elements and swaps them. Now, this is kind of like, it's a bit slow, but it's easier to understand. The way it works is it looks at a disordered list or data set, as the case may be, and it says, let me quickly, I don't think there's any example here, so let me just quickly, run something very quickly so that we don't spend so much time on it. And say, for example, the data set is 1, 3, 2, 6, 4, 9, 5. Now this is unsorted, right? And the algorithm wants to sort it using bubble sorted, right? It's okay, right? It then does what is called, okay, 1, what should follow next? 2, then it looks at it 3, looks at it 6, it looks at it 4, looks at it 9, looks at it 5. And then it runs through it again. It's still not sorted, right? It runs the same process again on it. It goes 1, to what should come next? 3, definitely. What should come next after 3 should be 4. So it goes 4, it continues 6, 9, and 5. And then again, until it finally sorts it completely out, right? And so it's slow, but at the end of the day, it's it's easy to understand for the algorithm. Now, for selection sort, it finds the smallest element in and places it in order. And so still using this example, where we have 1, 3, 2, 6, 4, 9, 5. It what's the smallest element? Definitely 1. What's the second smallest? Definitely 2, 3, 4, 5, 6. And like that, the algorithm places the algorithm fine-tunes the data set until it's perfect. And so it's sort of like, for example, if you're playing cards one by one, the algorithm finds the solution for you, finds the smallest and sets it up from the smallest to the largest in proper order. Now, for merge sort, the algorithm splits the data set into half, into 2, and then sorts out each half or each split of the data set, orders it, puts it in an orderly format, and then merges the data set back together. Now, it works very efficiently for exceedingly large data sets, example, real world applications, real life applications, and the likes. Now, for quick sort, it picks an element and sorts other elements around the elements it picks. And, it's, for example, let's take this example where we want to do a quick sort on this. Let's say it picks 6 and says, okay, what are the other elements? 1 definitely comes before 6. What are the other elements? 2 definitely comes before 6. 3 comes before 6. So it does it that way. 1, 2, 3, 4, 5, 6. Then, okay, what's the remaining one? 9. 9 definitely comes after 6. And so it arranges it that way. Right. And so we're able to get an order out of a disordered data set using the quick sort technique, sorting technique this way. Right. Okay. This here is quick sort, and this is the code. You can always go through it using, for those of you that have Python, now you'd again have to follow the artificial intelligence class and to get an in-depth understanding for Python programming, which we're not going to go through in this course. Now, introduction to algorithms. What is an algorithm, right? What's an algorithm? Let's see who amongst us wants to have a go at an algorithm. Okay, there's a message in the chat box. I've been having difficulty with network issues at my end. I guess all right. What is an algorithm? Let me call on Anastasia. Hi, Anastasia. Hello. Hi. Good afternoon. You have any idea, or you want to take a wild guess at what an algorithm is?
Maybe a wild guess. Maybe it's a repetitive. Maybe like.
Okay. So I appreciate you, Anastasia. Thank you so much. I appreciate it. Now, an algorithm is a step. Okay, let me go back to my screen. right? So an algorithm is a sequence of precise instructions that operate on data, like a step-by-step instructions or rules designed to solve specific problems or tasks from data. Now, if, for example, I want to, let's assume I feel lazy today, right? And I don't want to cook. I don't want to do anything in the kitchen. And a humanoid robot with me. And I wanted to know how to cook on the days I'm lazy, right? I would tell it, I want it to know how to make tea on the days I'm lazy. I'll program it in such a way, I would say, when you go to the kitchen, you find the kettle or the pot, as the case may be. You pick the pot, you fill the pot with water, you boil the water, you take milk from the cupboard. Now, those are step-by-step instructions on how the machine or the computer or the digital device, as the case may be, or the operating system should interpret, process, and work on and with data. That's an algorithm. And so it
We can't hear you. We are lost
includes
there. Voice is
plans,
breaking.
instructions, and the likes.
Hello, Mr.
Computers can
Jonathan. Can you hear me?
only execute a finite, predefined set of instructions exactly as.
Hello,
Can
Mr.
you hear me
Jonathan.
now? Can you hear me
Yeah,
now?
your voice was breaking a
Can
little
you hear me
bit, so
now? Hello?
take it. Yes, I
Hello?
can hear you now.
Hello? Can you?
Yes, I can hear you now, but your voice was breaking, so probably you need to
Oh,
take
okay, okay. All right,
introduction to
okay.
algorithms again.
Okay, so recapping on algorithms, I said an algorithm is a step-by-step instruction or rules designed to solve specific problems or tasks using data. Now, these algorithms could be instructions, could be plans, laid down to operating systems, softwares, machines, as the case may be. Now, I now give an example. I said, assuming today I feel lazy, and on the days I feel lazy to cook or to make tea, as the case may be, I want an operating system or a humanoid robot to know how to make tea on my behalf. I set an algorithm for it, and I say, when you step into the kitchen, you'd find my pot or my kettle, as the case may be. Take the kettle, fill it with water. When you fill it with water, boil it. When you boil it, you would always find my milk or my coffee in the cupboard. When you get the coffee or the milk, you put it in, you stir it, and voila, I have tea, right? Now, those are what or that is rather what is referred to as an algorithm. It's a step-by-step instruction on how to solve a particular task, right? Now, computers can only execute a finite predefined set of instructions exactly as instructed. If you remember the instructions I'm giving my operating system, software, or machine, as the case may be, to help me make tea on the days I'm lazy, which is why programming, it feels like a different way of communicating, right? To machines. Compared to natural human languages. Now, a program is an implementation or realization of an algorithm written in a formal programming language. Although each programming language is different from all others, there are still common ideologies across them. You have programming language, you have C, you have C#, you have JavaScript, you have Python, you have there are multiple, there are a couple of others I can't remember off the top of my head right now. Now, the study of data structures and algorithms focuses on identifying what is known as canonical algorithm, a well-known algorithm that showcases design principles helpful across a wide variety of problems. In this chapter, rather than focusing on programming details, we'll focus on algorithms and the ideas behind them. Now, on to understanding data structures. For many real-world problems, the ability to design an algorithm depends on how the data is represented. A data structure is a complex data type with two equally important parts: a specific representation, number one, of organizing a collection of more than one element, which is an individual value or data point. Number two, a specific functionality or operations such as adding, retrieving, and removing elements. Now I'm going to explain this too. I'm going to break them down for you. Now, a specific representation or way of organizing a collection of more than one element is what we looked at here. It could be a list, it could be an array, it could be they're also non-linear. So just a second. So now it could be trees, it could be graphs, and the likes.
Hello, can you hear me, Mr. Jonathan?
Yes, I can. Can you hear me?
Yes, I can hear you clearly, but there is something covering your skin like a red box.
Oh, I apologize, please.
Okay, now it's better now. It's better now.
Okay, all right, all right. Okay, so it could be lists, it could be arrays, it could be trees, it could be graphs, it could be hash tables, right? Now, those are ways of representing data. Now, for lists, arrays, and the likes, those are linear data structural representations. For non-linear data structure representations, we have the likes of trees, we have the likes of graphs, we have the likes of maps, we have the likes of hash tables. Now, those are non-linear data structural representations. Can you still hear me, please? Hello?
Yes, I can hear
Hello?
you loud and clear. I can hear you loud and clear.
Hello?
Yeah, I can hear you loud and clear.
Hello,
Oh,
Go
can you
ahead,
hear?
sir. We can hear you.
all right. Okay.
Not this
All
black
right. All right.
something again
Thank you.
on the screen.
Okay. So part which is this. Okay, I apologize. I apologize. Now, for the second part, which is a specific functionality or operations such as adding, retrieving, and removing elements. Now, that is the mode of operation for modifying the data set. And so if I have a data set, for example, if I, again, using the example of my location and my quote unquote, my properties. Now, if I come into an apartment, I come in with, for example, let's say I just come in with a bed and a fan, right? Just those two things. Let's assume I don't even have a shoe. I don't have any other thing, just bed and fan, right? With time, I start getting myself a shoe, right? Now, the bed and the fan is my original data set. To modify that data set, I have to be able to add to it or subtract from it. Now, in this case, I bought myself a shoe or a pair of shoes. I have to add those pair of shoes to my data set, which is my original data set of properties or belongings, as the case may be. And so I have to carry out an operation on my data set, which would add new elements to it. If I'm selling my bed doesn't belong to me anymore. And so my data set has subtracted the element of bed. I have to remove that element of bed from my data set. And so that's what is referred to as specific functionalities or operations such as adding, retrieving, and removing elements. Now, in our previous example, a string is a data structure for representing sentences as a sequence of characters. right? If you remember at the beginning of the lecture today, we spoke about how operating systems, machines, autonomous intelligence machines are programmed to be able to interact with humans using string data sets, right? Such as how are you? How was your day? How are you doing today? Where do I pick up the package from? Or when an autonomous vehicle is asking you, do I turn left or do I turn right? And you speak back to it and say, I want you to turn left. That is, it's communicating with you using the string data set. It's programmed that way using the string data set. Now, although the values of complex data are often diverse, computer scientists have designed data structures so that they can be reused for other problems, right? For example, rather than designing a specialized data structure for sentences in every human language, we often use a single universal string data structure to represent sentences, including characters from different languages in the same sentence. In addition, computers take time to execute algorithms. So computer scientists are concerned about the efficiency in terms of how long an algorithm takes to compute a result. Understandably so, depending on the data structure, the data size, and the data complexity, as the case may be. Now, among the different types of universal data structures, computer scientists have found it helpful to categorize data structures according to their functionality without considering their specific representation. Now, an abstract data type consists of all data structures that share common functionality but differ in specific representation. Examples of this are list. Lists and sets are common abstract data types used to represent complex data and can be in the form of integers or string data. Now, we have the example here of the list. Again, if you remember, I said when you are computing a list data set or a set rather, for a data set, when you're creating one or you're programming one, it always starts with the index of 0 and up onto the positive integer. However, if you're counting your index from the last element in your data set, it always starts from -1. And so the first element is always 0. The last element is always -1. And so if I'm counting from 98, the index for 98 will be -1, -2, and the likes. If I'm counting from 22, the index rightfully so is 0, 1, 2, 3, 4, 5, 6, 7, and upwards. Okay, common abstract data types for complex data follow and list and set types are shown in the image above. Now we'll discuss each abstract data type in more detail together with their data structure implementations. A list represents an ordered sequence of elements and allows adding, retrieving, and removing elements from any position in the list. Like we discussed before with the example where I mentioned if I have a property on beds, and I can't remember the second one, but if I have a property and I have to buy more things, then I add it to the list. If I have to sell some of the properties or belongings, I remove them from the list. And now that addition and subtraction are operations that are carried out on the data set, right? On the list or the data set, as the case may be. Lists are indexed because they allow access to elements by referring to the element's index, which is the position of the element in the data set. Address for an element in the list. For example, a list can be used to represent a to-do list where each item in the list is the next task to be completed in chronological order. And so fit scenario for this example, where each item in the list is the next task to be completed in chronological order, would be an example such as a linked list, right? Where we can use data algorithms of queue, first in, first out, whereby the first thing on the list is the first thing to be is the next thing to be executed and taken off the list. And so that's called first in, first out queue algorithms for data structure. Now, a set represents an ordered collection of unique elements and allows adding, retrieving, and removing elements from the set. Sets typically offer less functionality than lists, but this reduction in functionality allows for more efficient data structure representations. For example, a set can be used to represent the names of all places that you want to visit in the future. And so this is a key distinguishing factor between the list and the set. Now, the list can have multiple elements that are repetitive in nature, right? The set only has unique values. And so if you repeat it, right, which is why I paused a bit, I'm trying to figure out if I remember correctly, so if I remember correctly, I'm going to make research on that very shortly. If
Hello,
I
Mr. Jonathan.
remember
Can you hear me?
correctly,
Hello.
uh,
Hello. Can you hear me, Mr. Jonathan?
in the of
Hello, Mr. Jonathan. Can you hear me?
identifying and stop.
I'm so sorry about that. I think the network issue just started glitching again. We'll be back to the class shortly. While we wait, if you're not following the class, you could just let me know where you are, and to have a better understanding, because I realize that most of us here have not installed Python or don't know how to use Python. To have a better understanding of Python, you can join our class. We have another class here at Transformation College where we teach you AI automation. So there we can talk, we have talked about Python very well, how to install it, how to use it. So it will do you a greater favor or a greater help for you to join that class and learn more about AI. So if you're just trying to even get just Python out of that class, that's fine. But I'm just saying this in case of people that don't understand how to install Python or how to get Python or how to use it. I think Mr. Jonathan is back here. Can you hear me, Mr. Jonathan?
Yes, I can. Can you hear me, please?
Yes. Your network was glitching a bit. Your voice was breaking, but it's quite better now.
Please, I apologize.
All
Forgive me, please. Network
right.
challenge.
Okay,
Yeah.
let me just
Yeah.
round up. And for the AI class, I will send the link in the chat box. Okay, the link has been set to the chat box. So if you're interested in learning how to automate AI and also learn Python and machine learning, you can just go there and join the group. All right, thank you, Mr. Jonathan. You can take over now. Thank you very much.
Okay. All right. So, I don't know if you followed where I was talking about the difference between a list and a set and the real world applications of a set. So we've discussed in relative detail about the real world application of a list, where I've given examples of my belongings, and that can be related to any other individual or scenarios as the case may be. However, a set can be emails, and so email spams and the likes, to avoid repetition in the data sets per se, as it is, because a set has unique forms of data elements which does not give room for repetition. Hence, it's useful where you're trying to filter out what's the word now? Unwanted information. You're trying to filter out duplicity of information, right? Those are some of the real world applications of a set. Now, just a second. A map represents an unordered association between key value pairs of elements where each key can only appear once in a map. Now, a map is also known as a dictionary and associated definition. Now, maps are often used in combination with other data structures. For example, a map can be used to represent a travel wish list. Each place that you want to visit on the map can be associated with a list of other things that you want to do when you arrive at the given destination. Real-world applications for these are Google Maps and any other no other life map comes to mind right now, even though I know that multiple exist, but Google Maps is what comes to my mind right now, right? So it's unordered. It's not sorted, as the case may be, right? Because you cannot. It's not linear, and that's the word. It's not linear, so you cannot place it in a sequential format. You can't you can't sort it out. You can't place it in an ascending or a descending order, right? A priority queue, the next on data structures will be a priority queue, which represents a collection of elements where each element has an associated priority value. In addition to adding elements, priority queues focus on retrieving and removing elements with the highest priority. Another example of this would be the first in, first out algorithm. And so you find real-world applications of this again involves
Hello.
autonomous vehicles where
Hello, Mr. Jonathan.
the algorithm. Can you hear me, please?
Yes, it's better now. I just wanted
Yes, can
to
you hear me?
advise. Yes, I can hear you now.
Oh my God.
I just wanted to,
Oh,
can you hear me? I can hear you clearly now.
yes, I can hear you.
I just wanted to
Okay.
advise that if you
Yes, I
can
can hear you.
probably move a little bit towards somewhere else where the network is a little bit better, because it just keep glitching and the sound
Okay.
would not be
Yeah.
audible for a minute and to come back, so they can
Oh,
easily understand and follow you up.
okay, please, I apologize again. Please let me change back to MTN. I was initially using MTN, but MTN started giving me problems, so I changed to Airtel. Now, apparently, Airtel is also giving me problems as well. So please, let me just change back to MTN. It might temporarily, the network might temporarily glitch while I'm changing. Please don't be upset with me. It's not going to take long. Just maybe.
All right, that's not a problem. Just kindly do that as soon as possible.
Yes. Can you hear me now, please?
Yes, we can hear you. We can hear you clearly.
Okay, okay. Please, I apologize once again. Let me go through the chat, the event where there are questions. Okay, all right. Now, let me close the chat box. All right, so uh, talking about the the place of application of priority of priority queue, uh, for example, when you place queue representation.
Hello, Jonathan. Hello.
Can you hear me very
It
well,
is you.
please?
No, we can't hear you. It's breaking. It's glitching terribly. Okay, we want to apologize for this. I mean, here in Nigeria, since the
Okay.
I cannot yet see your screen from here, and I think you're still glitching.
Okay, so we've concluded on the priority queue for graphs. Please, can you see my screen now?
Yes, I can.
Yes, I can see your screen.
Okay. All right. Okay. All right. So a graph represents, I was saying a graph represents binary relations among a collection of entities. More specifically, the entities are represented as vertices in the graph, and a directed or undirected edge is added between the two vertices. For example, a friendship graph can be used to represent relations between people. Applications for this would include the applications in social media networks. For example, the likes of the Instagrams, the Facebooks, the Twitters. They make use of the graphical data structures to determine the likely friend lists, and as well as the already existing friend lists for individuals within the social networks, as the case may be, right? Then we have selecting a data structure. Now, since data representation is a fundamental task in designing algorithms that solve problems, how then do we select data structures for particular problems? Now, as computer scientists, we apply top-down approach to making this selection. The first will be select an appropriate abstract data type by analyzing the problem to determine the necessary functionality and operations. Hence, you must first understand the problem you want to solve. You must next understand what kind of data operations are necessary to solve those problems. Only then can you be able to decipher and say, amongst these multiple data structures, which would serve the purpose on ground, or the purpose at hand. Now, select an appropriate data structure by quantifying the resource constraints, usually program running time, as well as going back to the beginning space, memory space that will be used to house the data. If you remember the data life cycle that goes from data creation to data deletion, including usage of the data, that includes processing, storage comes before usage, storage, then usage, right? Then sharing the data with the appropriate authorities or personnel, then archiving or deletion of the data, right? And so selecting an appropriate data structure by quantifying the resource constraints, usually the program running time. I would also add the space, that is memory space, that you need to work with, right? Now, the primary concern is the data and the operations to be performed on them. Now, thinking back to simple data types like numbers, we focused on addition, subtraction, multiplication, division, as the case may be. Likewise, to represent complex data types, we also focus on the operations that will most directly support our algorithms. Now, after deciding on an abstract data type, we then choose a particular data structure that implements the abstract data type. Just a second, right? And so lists and sets are common abstract data types used to represent complex data and can be in the form of integers or strings. However, what do you do when your data is in an image format? What do you do when your data has to be in a mapped format? What do you do when your data has to be in, how do we put it now? In a tree format. For example, real life utilities of the tree data structure involve family trees. Now, for example, family trees cannot be in sequential formats or linear formats. And so I, for example, I have a father, I have a mother. My father and a mother gave birth to me. I would, at some point, we all on this group chat, some of us are even already parents, you know, and so the family tree continues that way. You have your children have their own children, each of the children. And so the family tree divides, goes down. And so not all data structures can afford to be in linear format or simplistic, right? Now, linear data structures, if a problem can be solved with an ordered sequence of elements, including numbers, payroll records, or text messages, the simplest approach might be to store them in a list, which is linear data structures, that is. Now, some problems require that actions be performed in a strict chronological order, such as processing items in the order that they arrive or in the reverse order. In these situations, a linear data structure, which is a category of data structures where elements are ordered in a line, is appropriate. There are two possible implementations for the list abstract data type. The first is an array list, which is a data structure that stores list elements next to each other in memory. The other is a linked list, which is a list data structure that does not necessarily store elements next to each other, but instead works by maintaining, for each element, a link to the next element in the list. Now, both array list and linked list are linear data structures because their elements are organized in a line or in a sequential format, one after the other. An advantage of an array list is that they allow random access to every element in the list in a single step. Hence, in other words, it's simplistic in format or in nature for the algorithm to carry out data operations on an array list, right? Now, this is in sharp contrast to linked list, which only supports sequential access. On the other hand, linked list supports fast insertion and deletion operations, which array lists do not. Now, earlier we introduced a set as offering less functionalities than list. Now, if you remember, a set has unique elements, right? And has far more lesser dimension. Hello, can everyone still hear me?
Yes, go ahead.
I can hear you.
Yes.
Okay. Okay. All right. Now, one
Yeah, I
drawback
can
of
hear you.
one drawback of relying only on linear data structures is related to the concept of efficiency. Now, even if linear data structures can solve any problem, we might prefer more specialized data structures that can solve fewer problems more efficiently and help represent real-world data arrangements more closely. And that takes us back to the example I gave of a nonlinear data structure, which I highlighted as a tree, whereby, for example, if you are dealing with data sets that have to do with family data, you cannot highlight that data within a linear data structure. It has to be operated on within a nonlinear data structure, specifically a tree data format, right? And so this is particularly useful when we have large amounts of data, like places or roads in an online map of the entire world. So you have other examples like map data structures, graphical data structures, and the likes. Right? Now, linear data structures ultimately organize elements in a line, which is necessary for implementing lists, but not necessary for other abstract data types. For example, how do you train a machine to be able to organize and recognize patterns, biological patterns in faces, right? That's facial recognition. You cannot use a linear representation or linear data structure as the case may be. You might be able to, in some cases within that, you might be able to use a linked list, right? Which would say, okay, this biological pattern links or leads to this other biological pattern. And this biological pattern, if you see a person's face becoming like this, maybe the person's face is getting wrinkled, but you cannot use a normal array list to carry out data operations on such kind of data, right? Now, this is the example we're discussing now, which is a family tree. And so you see the root element, otherwise called the parent. Then you have child A, child B, child A gives birth to child AA, and child AB. Child AA gives birth to child AA. Like that, the tree continues growing. Now, that's not something you can afford to put in a list or a straight line, right? Because the data becomes more diverse, more complex. Real-world applications include machine learning programmings. Yes, machine learning programmings, it can also be used for I'll check again. It can also be used for facial recognition. I'm talking about the tree data structure and the like. So tree data structures. A tree is a hierarchical data structure. Now, while there are many kinds of tree data structures, all of them share the same basic organizing structure. A node represents an element in a tree or a graph. So anywhere you just see node, automatically you know that we are talking about an element. Now, often the primary node is referred to as the parent node. Now, trees maintain a hierarchy through parent-child relationships, which repeat from the root node or root element, as the case may be, at the top of the tree, down to each leaf node. Now, which is at the bottom of the tree. The height of the tree corresponds to the depth of the data in question. And so as the data in question continues growing, the tree or the tree data structure definitely continues expanding. And so we have multiple types of tree data structures, which we'll definitely be looking at next week. And we'll be covering everything that remains on the course next week. For now, we have the cyber security coming up 1:30, and I will leave that to my boss to give an introduction to.
All right, thank you very much, Jonathan. It's been very interactive this afternoon. It's been interesting since morning, even though the network service providers will not allow us to have a smooth run of the class, but we've made a good use of the time. So thank you very much. Please let's appreciate Jonathan. Let's appreciate Jonathan in the chat room while we make welcome the trainer for the cybersecurity side of things today. And that's no other person but Joseph Itoje, right? Joseph will be taking us on the cybersecurity side of things. Last week, Saturday, we started off looking at the top 10 OWASP